One of the ways that we often encounter and inequalities is in the form of one of these between inequalities. So we might have, for example, the inequality 3 is less than or equal to 4x minus 1 is less than 7. This means the same as 3 is less than or equal to 4x minus 1 and 4x minus 1 is less than 7. And now we can solve this just like we would any other compound inequality. Solve this inequality, and then solve this inequality, and then connect them with the word and. But you may have noticed a certain repetitiveness in this process. We added 1 to both sides here, we added 1 to both sides here. We divided both sides by 4 here, we divided both sides by 4 here. If we like, we can solve a betweenness inequality by manipulating all 3 parts at once. So I'll add 1 here, here, and here. I'll get 4 is less than or equal to 4x is less than 8. And then I'll divide by 4 here, here, and here. And I'll get 1 is less than or equal to x is less than 2. Which, of course, by the same logic that gets us from here to here, we can get from here to here, so these really are the same answer. Now, we don't have to do this. We can always split this up and write it as 2 separate inequalities. If you find that you get lost in this process, just use this process instead. Now, in order to write one of these between inequalities in the first place, I need to have this left end smaller than the right end. Right? I need all 3 inequalities to be true. I also need 3 is less than 7 to be true. And the result of that is a between inequality, a problem that's given as a between inequality, or anytime we end up with one. It's always an and type compound inequality, and it's always type 1. Remember, that was the picture with arrows in opposite directions that overlap. When we have a type 1 and inequality, maybe we've solved some inequality and gotten to this point, we can write our solution as a between inequality. Let me show you how. Suppose I have this compound inequality. I solve it by solving each inequality separately. Subtract 5, divide both sides by 2. Over here, subtract 4, divide both sides by -3. And when I do that, I need to flip the inequality. So I get x is greater than 1 and x is less than 6. Right, now we could draw the picture and confirm that this is a type 1 and inequality, but it is. How should we write this as a between inequality? First, we'll rewrite so both of our inequalities are either less than or equal to. Right, here I have x is greater than 1. That's the same as 1 is less than x. This one's already less than, so I don't change anything. Second, write the 2 inequalities in the order that puts x in the middle. Right, I could write this as 1 is less than x and x is less than 6, or I could write it as x is less than 6 and 1 is less than x. Right, it doesn't matter which order I think about those in. This order puts x in the middle, so this is the order we want. If you can't do it, if after they're both less than inequalities, you can't write it so x is in the middle, you didn't have a type 1 to begin with. So you're not getting a betweenness inequality out of this. All right, and the last step is to just merge the 2 x's. Instead of writing 1 is less than x and x is less than 6, write 1 is less than x is less than 6. And that's all there is to it. So just to practice this, I'm going to have you write the compound inequality. X is greater than -5 and X is less than or equal to 7 as a between inequality. Pause the video and try this now. All right, first I'm going to write them both as less than. Instead of X is greater than -5, I'm going to write -5 is less than X. This one is already less than. X is less than or equal to 7. Right. These are already in the order where X is in the middle. So I just have -5 is less than X is less than or equal to 7.